going to do a little deep dive of what I presented at the ASEE conference this past year, and also give a little bit more background and motivation to where that came from. So I'll just get right into it. Let's see. All right. So the motivation is really team-based projects. They're used all across the undergraduate curriculum, from introductory to senior design courses and throughout required elective courses. With that said, these projects, right, they might just be a single project that a team of students are working on, to a term project, to, as I mentioned, senior design. And so students need to work together to figure out who's doing what. They may need to present together, and oftentimes those dynamics are complex. It can lead to conflict, it can lead to misunderstandings. And more often than not, when you ask students if they've received formal instruction in their undergraduate careers on how to work effectively on a team, more often than not, they say no. And it's something they just learn in high school and then further develop in college. So with that said, professors often do not feel qualified to teach these specific team dynamics skills and tools in their particular classes. And so that was sort of the motivation to some of the work that we've been working on over the last few years. So specifically, one approach that we've tried is this ASEE-based approach. And so this is an approach where once teams are formed, students articulate the experiences and backgrounds that they've had in their lives in general, not just in college. And they come together and they share about their assets and experiences. And then they use that to dictate and determine who's going to do what on specific course deliverables. So back in 2021, I presented some of this work in integrating this into our freshman introductory to biomedical engineering course. And this whole asset-based approach was primarily used as a planning tool. So teams would undergo, they would complete what we call asset-based cover sheets to decide who's doing what, and they were asked to articulate the reasons for why they distributed the workload the way that they did based on these assets or experiences. So when we surveyed students at the end of that course, they felt that the usefulness and impactfulness was positive of this approach in their freshman year. And so we went ahead and decided to try it in the senior design course. In the senior design course, we implemented it very similarly, but the feedback was not as positive. And some of the sort of comments that I received was, by senior year, we've already worked together, we know each other, we spent too much time working on teaming exercises, and they didn't have the same sort of positive attitude about it. And so with that said, something to highlight, right? The introductory course is 1 quarter long, so that's 10 weeks at our institution, versus the senior design course is the entire year, so that's 30 weeks. And so over the course of 30 weeks, asking them to do these asset-based cover sheets and whatnot didn't have the same impact. And so what we felt was that really, more than just setting up the students for success at the beginning, really the impact of regular peer feedback in this sort of longer term course seemed to be more valuable. And that was sort of what spurred on some of the work that I'm going to talk about today. So I thought I would just give a little background introduction to our senior design course at Davis, so that you can sort of see how the 30 weeks is broken up. So the objectives, like most, if not all of our senior design courses, is really to deliver something of value that meets our end users. Teams work with typically a clinician client, and then also to demonstrate and document their understanding of the design process. So as I mentioned, it's the entire academic year. Our enrollment 75 to 100, and typically we'll have the primary instructor as well as 4 to 5 graduate teaching assistants, and anywhere from 4 to 5 students per design team. And so as teams are formed by week 1 of fall quarter, they have essentially 4 major written deliverables and 4 major oral deliverables over the academic year. And so I thought I would just quickly go over what those are. So in fall quarter, so the first 10 weeks, students sort of undergo the needs finding process, as well as through survey analysis, background research, identify, as well as state-of-the-art analysis, identify all of their preliminary engineering design specifications and functional requirements that their design solution should satisfy. And this is sort of articulated in a group written progress report, as well as a group oral presentation that they give in front of a design review panel. And then together as a team, they also have to maintain their design history files, which documents their engagement with the design process. So by the end of fall quarter, they've conceptualized different design solutions and started the concept selection process. In winter quarter, they have their second written and second oral deliverable, where this is where they're really articulating their final design solution and detailed design. They essentially come up with their detailed manufacturing and prototyping plan, order all of their materials, and begin prototyping and testing. And by the end of winter quarter, they've planned out all of their verification and validation tests to see how well their solution meets both their specifications as well as end user needs. And again, they're continuing to prototype, test, and maintain their electronic design history file. And then by spring quarter, they've got their final written report as well as final oral design review. And then this is essentially where they're, showing their final outcomes, showing the outcomes of all of their testing procedures and whatnot. So all that to say, the teams are working together a lot throughout all 30 weeks. And so what I wanted to do was highlight really the teamwork design timeline in terms of what specific team activities or what specific team deliverables they're doing to evaluate their teamwork skills. So in the first quarter, what we did was once the teams were formed, we replaced those earlier asset-based activities with in-class teamwork discussion and activities. And so one of the things that we do in class is this yes and activity, which actually I got from an idea from an education showcase from, I believe it was Dr. Alyssa Taylor at UCSD, where really we take some of the principles of the individual asset maps, but we do it as an in-class improv activity within teams. We then spend some lecture time talking about Bruce Tuckman's team development model, just so that students can understand that there are different stages to teamwork as they begin to work together more and more. And then finally, we give some formal instruction with respect to guidelines on how to receive feedback from their peers. We have them sort of read a set of team guidelines, sign a team contract, as well as articulate some of the expectations and culture and deliverables that they want to have as a team. So this is upfront in the beginning of fall quarter. And then 4 times throughout the course, we essentially conduct peer evaluations using CATME. And so if you've implemented CATME in your courses, it's just a really nice online tool that students can evaluate themselves as well as their peers within these 5 particular areas. And so this is sort of a snapshot of what that looks like. Essentially, each student rates themselves and their teammates on these different descriptions of behaviors. So this is for contributing to the team's work, and there are a couple sentences that describe what that behavior may look like. And then in addition to the rating, the students can then provide comments to the instructor as well as to each of their teammates. And so they'll receive this note where it says the survey is currently set up so that your teammates will read your comments, but will not know that it was you that wrote them. And then there's a section where the student can write confidential comments to the instructor as well. And so the default setting when you enable peer-to-peer comments in CATME is that they will automatically release to the students once you release the results of the peer evaluation itself. And then the students will essentially receive a group of comments from their teammates, but they are anonymous. And so when we first started implementing this, I thought that this would be a great way for students to receive feedback, but in the end, it ended up being very messy. If you can imagine, I would say a lot of the students are very polite, and their criticism is constructive in these sort of free form comments. But there were often times where there were, quite frankly, comments that students were offended by. And the features within this tool didn't enable you to pick and choose which comments to release. It was sort of an all or nothing feature. And so because of that, we switched over. There's another setting where you can enable peer-to-peer comments, but decide later to not automatically release them. And so what we did was we held back, and the teaching assistants of the course essentially manually summarize the comments for each student on the teams that they mentored, and essentially summarize them and sent the summary in their words to each student. And so this was much more well received by the students on the teams. They had a filter go through them. But as you can imagine, it was extremely time consuming for the teaching assistants in the class. And so I guess this is sort of why we ended up implementing using ChatGPT to essentially summarize our comments. And so this is just an example set of peer comments that one might receive. And then essentially what we did was we, again, used ChatGPT, where, as you can imagine, you have full freedom with the prompts and how you want the output to look. And so this is just a quick example. Please summarize this peer feedback for senior biomedical engineering student as positive and constructive feedback in a friendly tone. And then I sort of copied and pasted those example peer comments. And you can see how the output of what ChatGPT did. You can also say rewrite as bullet points. And again, you can just play around with the format. And so by doing this, it really, it saved a lot of time for the teaching assistants, as well as when I did it as well. And it also just normalized the language that was used in the feedback back to the students. Again, it's just really just to highlight that you can, this is another set of peer comment examples. And so, whether there are positive or more constructive criticism type comments, right, as you can imagine, ChatGPT can write it in a way that's just a lot easier to digest and swallow. You can choose whether or not you want to incorporate names and whatnot. So it's just a really simple fix that we implemented in our course. And it just, with a course of 75 to 100 students, it really just helped with time efficiency when it came to giving back that peer feedback. Once we started implementing this, I never heard any comments from students regarding, just being offended by the peer comments that they received. And I just felt like it had more of a positive impact. And so in just general, the key takeaways, it still allows students to be completely honest in their feedback in those peer evaluations. Again, the TAs could more efficiently summarize the peer comments. It didn't take as much time. I mentioned, it really normalizes the language that feedback is given across all teams. We've got 4 to 5 TAs where each TA will mentor 4 teams. And so before using ChatGPT, the quality, the language of even the summarized feedback varied quite a bit. And then, as we all know, prompt engineering, ChatGPT prompts can continue to be iterated upon based on the type of feedback that you're trying to give to your students. So this is sort of what I presented in the showcase. I just wanted to do a quick thank you to the TAs from our senior design course this past year, who really were our guinea pigs in implementing this. So that's sort of all I had prepared. I'm happy to take questions